Hello everybody and welcome to lesson 13, Balanced Transportation Problem Solution. Previously in lesson 12 we have discussed how to formulate transportation problem from a real business problem. Once we get the formulated transportation problem or transportation model we can say, so the next task is to find out the initial solution for the problem. Thus, the objective of this lesson is to find the initial feasible solution for the balanced transportation problem. The methods of finding initial feasible solutions are commonly three. The first one is northwest corner method, the minimum sale cost method, and the last one is Vogel's approximation method. And we will do examples with all of them. Let's start from northwest corner method. These are the steps how to use northwest corner method to find out the initial feasible solution for the transportation problem. So the first step is find the northwest corner cell, that is X11 of the transportation tableau. And then the second is allocate as much as possible to the selected cell. And the third is adjust the associated amounts of supply and demand by subtracting the allocated amount. And the fourth is cross out or cancel out the row or column with zero supply or demand. Let's move to an example. The per unit transportation cost from source to destination are given in the following table. Thus, find the initial feasible solution using northwest corner method. Before that, let's check whether it is balanced or not. So, to check that, we have to add the total demand 10 plus 10 plus 10 plus 10, so it is 40. 12 plus 17 plus 11 is 40, so it is a balanced transportation problem. Then the first step is to identify the northwest corner cell. The northwest corner cell is 50, as you see here, it is 50. So we have to see the supply which is corresponding to this cell and the demand. So among this, we have to assign 10, which is the smaller one. So we have to assign 10 to the X11 cell, or we can say the northwest corner cell. So after allocating 10, we have to adjust the supply and demand. So when we adjust the supply and demand, so here we have to subtract 10 from 12, so the remaining is 2. 2 is unassigned still, and here we just move 10 to here, so we already assigned, so we can cancel here. We have to cancel 10. And the next task is to cancel out the row or column with zero supply or zero demand. So this column has already zero demand. So we have to cancel. We have cancelled. And the next task is we have to repeat the steps once again. Repeat step 1, that is we have to find out northwest corner from this region. That means this region. We have to find out the northwest. So the northwest corner is 75. So correspondingly, we have here 2 and we have here 10. So 2 is smaller, so we have to assign 2 here. Then we have to adjust the supply and demand. We have to adjust supply and demand. So here we have to cancel out 2 because it is moved, and we subtract 2 from 10 and the remaining is 8. And the last is cancelling out the row or the column having 0 demand or supply. So as you see, this row has already achieved or allocated all the supplies, so it is 0. So we have to cancel out the first row. So we have cancelled out. And the next task is to repeat the step again by finding the northwest corner from this region. So from this one is the northwest corner. So the corresponding supply and demand is here there is 8 and here 17. So we have to assign 8. We have to assign 8, which is the smaller one. Then we have to adjust the supply and demand. That means subtracting 8 from 17 and remain 9. And when we subtract 8 from 8, so it becomes 0. And the next step is to delete or cancel out the row or the column having 0 supply or demand. So this will be cancelled, right? This will be cancelled because there is no demand. So we have to shed this. And now we remain with these cells. So from these cells we have to repeat the steps and we have to find out the northwest corner cell. So the northwest corner cell is 40 and correspondingly there is 9 and 10, and we have to allocate 9 because 9 is less than 10. So when we allocate 9 should so when we adjust, so 9 will be cancelled and 10 minus 9, here we remain with 1. And then the other step is to cancel out the 0 supply or 0 demand row or column. So here the supply is already finished, so we have to cancel this row. And we remain with these cells, these 2 cells. Once again, we have to repeat the steps. And the step 1 is to determine the northwest corner. The northwest corner is obviously 50. So correspondingly, there is 1 and 11. So we have to move 1 to this cell, and then we have to adjust the supply and demand. So 1 is moved here, so here we have to cancel 1, and 11 minus 1 here remains 10. So then we have to cancel out the column because it is already, the demand is achieved or finished, so we have to highlight. And the remaining cell is, as you see, the remaining cell is only 1. So the northwest corner is itself, that's 55, and the corresponding numbers is 10 and 10. So we have to assign 10, and let's adjust 10 minus 10, 10 minus 10. So cancelled, or it can be cancelled, it can be, or it will be 0 when 10 subtracted from 10, so it will be 0. So we have to shed. So we already assign all the supply to the demands. Okay, from this table we can understand that all supply and demand are allocated. All the supplies are allocated to the demand. Thus, the total cost can be obtained as follows. we just multiply 50. 50 means, we remember that 50 is the per unit cost, and 10 is the number of items to be transported. So we can multiply 50 by 10 plus 75 by 2 plus 80 by 8 plus 40 by 9 plus 50 by 1 plus 55 times 10, like this here. So the final total shipping cost using northwest corner method is 2,250. And we can also say that there is a transportation from, or there is a distribution of items from S1 to D1. There are 10 items from S1 to D1, and to D2 2 items, and from S2 8 items for D2 and 9 items for D3, and from S3 1 item for D3 and 10 item for D4. This is the overall distribution, how the items is distributed to the demand or the warehouses. Let's move to the minimum sale cost method. By the way, the unit transportation cost played no role in northwest corner method. We didn't consider any cost, whether it is small or not, so we just ignored the unit transportation cost in the case of northwest corner method, which simply selects the upper left hand corner variable and assigns to a value to it. But with the minimum sale cost method, the initial allocation is made to the sale with the lowest cost. Thus the solution becomes near to optimal solution. The solution becomes near to optimal solution than the northwest corner method. Let's see the steps. The steps of the minimum sale cost method are as follows. The first one is select the least cost among the per unit cost table, and the second step is allocate as much as possible to the feasible sale, and third, adjust demand and supply, and the fourth is cancel the row or the column with zero supply or demand. By the way, in short, the difference between the northwest corner method and the minimum sale cost method is that in the case of northwest corner, we just select the upper hand corner variable and assign a value. But here we have to first select the minimum sale, the minimum cost sale, and then we start assigning. The remaining steps are the same. Here is the only difference. Let's solve the previous example using least cost method. We have already solved this example using northwest corner method, and now let's repeat with least cost method. So the first step of least cost method is to select the least cost among the per unit cost table. So from this table, when we see the least cost is, as you see, 30. 30 is the least cost. So the next step is, after selecting the least cost, the next step is assigning for this sale. So we have to assign 10, 12 here. So we have to assign 10 because 10 is smaller than 12. So the second step is to assign, allocate to the sales. So 10 is assigned, and we have to adjust the supply and demand, and supply and demand is adjusted. 10 is cancelled just, and here 12 minus 10 remaining 2. So 12 is cancelled, and there is a remain of 2, which is unassigned. And the next is we have to cancel the element or the row having zero demand or supply. So we can cancel this D3 column because 10 is already here cancelled. And the next task is, again, we have to repeat these steps. So we have to just find out the minimum sale, the minimum cost sale, the list or the least cost sale. So from this, let's see, here there is 45, but here there is 40. 40 is the minimum, right? 40 is the minimum. So we have to choose 40, and we have to assign. The next step is to assign for or allocate to this cell. There is 10 and 11, so we have to assign 10 here because it is smaller. Then we have to adjust. So here we have to cancel, and we have to subtract 10 from 11, and the remaining is 1. And the next is we have to cancel out the row or column with 0 supply or demand. Here's 0 demand, so we have to cancel this D1 column. D1 column is cancelled, and now we remain with 2 columns. So from these 2 columns we have to select the minimum cost sale. The minimum cost sale. So the minimum cost sale is, as you see, 45, right? From this and from this 45. So we have to assign for 45. There is 10 here and 2. We have to assign 2 because it is smaller. So let's adjust the supply and demand, and from here we subtracted 2, so it remains 10 and 8, and we cancel 2 because it is already assigned. And now let's move to delete the column or the row having 0 supply or demand. So here the first row is 0. The first row has 0 supplies, so we cancel the first row. And the next task is to repeat the steps, and once again we have to select the least cost cell from these 4 cells, 1, 2, 3, 4. So 55 is obviously the least. So 55 is the least, and then we have to allocate, assign for 55. The corresponding numbers are 8 and 1, so we have to assign 1, and we have to adjust the supply and demand. 1 minus 1 here, 1 should be cancelled, and 8 minus 1, there is a remaining of 7. And then after, the fourth step is to cancel out the 0 demand or supply column or row. So this row has 0 supply, so we have to shed this row. Okay, now we remain with 2 cells, 80 and 60. So from this, the smallest is 60. So we have to allocate for the 60s. The corresponding is 7 and 17. So we have to allocate 7 here. We have to allocate 7 here. Then we have to adjust the supply and demand. 17 minus 7 remains 10, and 7 minus 7 remains here 0. So the next task is to delete the row or the column having 0 demand or supply. This, as you see here, all are assigned or allocated, so we can cancel this column. Okay, then the remaining cell is only 80, so we can assign 10 to 80. 10 is the least because it is the only number, so we can assign 10, 10, 10, 10. So when we assign 10, we can make it them 0 because 10 minus 10 is 0, 10 minus 10 is 0. So now we can cancel the row as well as the column because the column and the row has 0 supply and the column has 0 demand. So we already assigned all the supplies to the demand So there is no leftover because it is a balanced transportation problem. Now we can calculate the transportation cost by just multiplying the per unit cost by the items allocated. So 30 times 10 plus 30 times 10 plus 45 times 2 plus 80 times 10 plus 40 times 10 plus 60 times 7 plus 55 times 1, and it becomes 2065, by the way, which is less than the cost obtained by northwest corner meter, that is 2250. So minimum cost sale is better. Minimum cost sale is better than northwest corner method. And to explain, this is the distribution from S1. As you see, from S1, 10 items goes to D3 and 2 items goes to D4, and from S2, 10 item goes to D2 and 7 item goes to D4, and from S3, 10 item goes to D1 and 1 item goes to D4. This is how to interpret or how the distribution of the item looks like. Let's move to the third method, that is Vogel's approximation method, or we can abbreviate like VAM. VAM is an improved version of the least cost method that generally, but not always, produces better starting solution than maybe the least cost method, but it is not always true. VAM is a technique which is built on the concept of penalty cost or regret, or we can say opportunity cost. If a decision maker incorrectly chooses from several alternative courses of action, a penalty may be suffered and the decision maker may regret the decision that was made. In a transportation problem, the course of actions are the alternative routes, and the wrong decision is allocating to a cell that does not contain the lowest cost. So if a manager incorrectly make a decision to transport with higher cost, so there is a regret or there is a penalty. So Vogel's approximation method uses the concept of this penalty or opportunity cost. Let's move to the steps of Vogel's approximation method. The first step is determine the penalty measures by subtracting the smallest unit's cost in the row or column from the next smallest unit cost in the same row or column. This penalty is actually a measure of lost opportunity. One forgoes if the smallest unit cost cell is not chosen. If the manager makes a mistake and selects the higher costs, so there is a regret or there is a penalty, or we can say there is a lost opportunity. And the second step is identify the row or column with the largest penalty, allocate as much as possible to the variable with the least unit cost in the selected row or column. And the third step is adjust the supply and demand, and the fourth one is cancel out the satisfied row or column. If the row and a column are satisfied simultaneously, so only one of the two is crossed out and the remaining row or column is assigned 0, supply or demand. Let's move to an example. The previous example, we also repeat that same example using Vogel's approximation method. This example is already done with the first two methods, the northwest corner and the least cost method. So step one. In step one, we have to find the difference between the list and the next list from the row and the column. So from this row, the list one is 40 and the next list is 45. So here we have to write the difference between these two. Here 15, and from the second row the list one is 40 and the next list is 60, so we have to write here 20, and here the list is 40 and the next list is 50, so we have to write here 10. And from this column, the list is 40 and the next list is 50, so we have to write here 10. And here 70 and 75, so we write here 5, and here 30 and 40 and 30, so we have to write here 10, and here 45 and 55, we have to write here 10. So like this, it looks like this. So from all these values, we have to choose the maximum, that is 20. 20 is the maximum one. So this row is chosen. This row is chosen. From this row, we have to select the minimum. The minimum one is 40. 40. So we have to assign for this cell for 40. So the correspondings are 17 and 10. So 10 is less than 17. So we assign 10 here, and here we remain with 7. We remain with 7. And the next task is to repeat the first step. The first step. Before that, we have to cancel out. Before that, we have to cancel out the already zero demand or zero supply column or row. So here, D3 is already achieved. So we have to cancel this. We have to cancel this. And now let's repeat the steps again. So from this row, we have to select the list and the next list, that is 45 and 50. So we write here 5. And from here, 65 and 60. So we have to write here 5. And here 40 and 45, we have to write here 15. And here from this column, 50 and 40. By the way, this column remains the same with the previous one, and it's also the same. It's also the same because it's already as it was. So the values looks like this. Now let's select the maximum from this penalty. The largest penalty is 15. So the corresponding row is this one. And from this row, we have to select the minimum, that is 40. So let's assign to 40, 10 is assigned, and 10 is subtracted from 11, so 1 remains. So the next task is to cancel out this column because it's already assigned. So we have to highlight. And now the next step is to repeat the steps from the remaining cells. We have 2 columns, D2 and D4. So the first step is a difference between 75 and 45. So it is simply 30. It is 30, 80, 60, 20, 70, 55, 15, and it remains the same. The columns remains the same, the difference remains the same. So the maximum is 30. So the corresponding row is row 1. So from row 1 we have to select 45. This one is 45 because it is least. So we have to assign to this 10 is assigned because it is less than 12. And here 12 minus 10, we remain with 2. And the next task is to cancel out the column or row which is satisfied. So D4 is already satisfied, so we have to cancel D4. And we have remain with 1 column, that is D2 column. By the way, as we see here, there are 2, 7, 1. The summation is 10, and we remain with 10. So we directly, no need to repeat the steps again because it is already clear. So we directly assign to 75, 7 to this cell and 1 to this cell. Then we cancel all this and we cancel also this. So we can allocate the supply column to D2 column, and then we can shed the D2 column. And the last table looks like this. So we already assigned all the supplies to the demand. So now we can calculate the transportation cost by multiplying the per unit cost with the items to be transported. So before that, we can interpret that from S1 2 items goes to D2 and 10 items goes to D4. From S2 7 items goes to D2 and 10 items goes to D3. And from S3 10 items goes to D1 and 1 item goes to D2. So we can just multiply 75 times 2 plus 45 times 10 plus 80 times 7 plus 40 times 10 plus 40 times 10 plus 70 times 1 equals 2030. By the way, this one is even less than that of the total shipping cost obtained from the least cost method, which is 2065. So as you see, the total shipping cost obtained using northwest corner is the largest, whereas the total shipping cost obtained using Vogel's approximation is the lowest. So it is better to solve, or it is better to use Vogel's approximation method. And Vogel's approximation method is somewhat near to the optimal solution, we can say. This is all about today's discussion, and I provided you an example to try by yourself. So here is the per unit transportation cost, which is provided in the table, and it is a balanced transportation problem. So try to use northwest corner method, least cost method, and Vogel's approximation method to find out the initial basic feasible solution. Thank you for listening. Have a good time. Bye.